Hello, this is Christophe de Dinchin, and this is my weekend status update about DB48X, which is an RPL implementation for DM32 and DM42 calculators from Swiss Micros. So today I'm going to talk about release 0.4.11, which provides support for RPL debugging, infinite recursion in RPL programs, various improvements in units from unit files, and numerous changes in settings. So let me start with relatively easy stuff, which is units. So if I go to my units menu here, you will see that there is a quick menu entry, and it's defined by the units.csv file on the disk that you see on the right, which, as you see, defines various units that I use often, like for instance inches. So if I want to convert inches to millimeters, I just go to the quick menu and I enter 12.2 inches, and I can convert that quickly to millimeters. So when I have an entry in this file, like this one, it specifies an actual conversion factor. You see that here I use an exact conversion factor, which means that if I set 1 inch and I convert that to millimeters, I get a result as a fraction. Now I also have entries like millimeters, kilometer, etc. that have an equal sign as the definition. And what this means is that these entries can be built from other units. For instance, the millimeter entry can be built from the milli prefix with the meter definition, and the kilometer per hour entry can be built from the kilo prefix applied to meter and the hour definition. Now, what is nice about having a unit file like this is that I can do conversions that the HP48, for instance, could not do, like change. So if I have, for instance, €1, I can now convert that. So let me, for instance, have 1.25 euro, and I can convert that to US dollar. Oops. So euro that I convert to US dollar like this. And of course, I might want to prefer to have a fixed 2 display with only 2 digits. That's typically what you would use when you're dealing with this kind of units. Let me use the back menu to get back to my units menu here. And I can very easily convert that to British pounds. And what is interesting is that because it's a CSV file, I can easily import that using a spreadsheet, for instance, from various sites that give you access to the daily updates for the conversion ranges. So it's relatively easy to produce this CSV file and have the rate change of the day in your calculator. Now, when you do these kind of things often, you may remember that there is the quick cycle key, which is the EEX key. And if I do this with, for instance, a number like this, and let me go back to standard display mode. So 12.2, if I hit EEX, then I get a fraction representation. Now, in the disk menu, there is something new that you can see at the top, which lets me have mixed fractions as well. So this is a new display mode where I can instead select mixed fraction instead of improper fractions. And I switch back and forth with EEX. Now, EEX can also deal, for instance, with complex numbers. So if I enter 2.5 with an angle of 45 degrees, and I do EEX like this, I'm going to have the polar form, the rectangular form for my number and back to my polar form. So this is very convenient, and if you apply this to units, well, you see the file on the right that defines my units has a section that begins with equal cycle, and that defines the cycling operation for the units that I care about. So for instance, if I want to convert quickly my euros to, so I have 12 euros and I do cycle, it's going to convert, as you can see, from euros to Swiss francs, to US dollar, back to euros. And if I do this with millimeters, because of this definition, it's going to cycle between inches, millimeter, and centimeters. So that's the definition that you see here. So it's fairly easy to have a one-click change between units that you use often. Now, of course, if you type a number and then EEX is going to be the normal entry of an exponent value. So that's the major improvement for the units file. Now, let's talk a little bit about RPL programming. That's something we have not covered quite as much so far. And in order to do that, just to improve the quality of the display, I'm going to switch to the simulator. And so the simulator is just the same application, but running on my computer here. And I have a number of demos. So for instance, I have this plotting demo that you may remember. Let me run the same plotting demo on a real calculator, and you're going to see that it's, oh, I think I did not load the states. So let me load the demo state. And now if I hit the var menu, I have, for instance, this plotting. So you see that plotting is not exactly as fast on a real calculator as on the simulator, but it's still pretty decent. So same result. Now, I might be interested in seeing how this program actually runs. So let me debug that. So I hit the Shift key and I get this program here. Now, if I hold the quick access menu, the tools menu, you may remember that this is the menu that gives me access to operations that match what is on the stack. So for real numbers, for instance, it gives me the real menu. If I have a base number, like for instance, oops. So I have a base number like this, and let me swap between the two. So if I hit the tools menu, I have the real menu, and if I have a base number, then I get the base menu. For programs, the tools menu gives me the debugging options. So let me switch to the simulator now just for the, because the picture quality is going to be slightly better, but it works really the same. So I recall this program here. I hit the tools menu and I hit debug. And now you see that I can single step through this and see every single step of my program and execute that as I go. Sorry, I think I went over. And when I'm done, I can hit continue. So that's F5, and that's going to finish my operation. So I can see, for instance, where there are errors inside my program and so on. So the various features that you have include stepping inside a program, stepping over, counting a given number of steps. So this is something that did not exist on the HP48. Let me try that with plotting, or let me see if I can have another example that would be interesting. So let me investigate the recurse program that shows another new feature. And so what this program does is that it adds one to the stack, draws it on the screen, and then displays amount of available memory and calls recurse again. Now, on an HP calculator, if you do something like that, then you're going to see the memory that goes down slowly as the calculator consumes more and more memory, and the calculator is also going to do the loop slower and slower. If I do this here, you see that my memory usage stays constant, and on a real calculator, it's not going to be as fast. But just to give you an idea of how this behaves there, and you can see that I have the same property, that the memory doesn't move except for the fact that the numbers get bigger and bigger, and so it's going to consume a bit more memory with bigger numbers. But that's about it. Now, if I interrupt the program, you see that it tells me interrupted. And I'm now in stepping mode. So same thing on the simulator. And so that means that I can now use my debugging capabilities. So I also have that in the programs menu and then F6 for debug. And I can step through my program and resume its execution. So I mentioned the steps command, and I can, for instance, step 10,000 steps. So this is really fast on real hardware. So let me show that on a physical calculator. So I go to the debug menu and I step 1000 steps. And you see that it's stepping through the steps, and then I'm back in interrupted mode and I can keep going. And the kill command is what is going to keep me out of the program. Halt is if you want to put a breakpoint inside the program, so you can use the halt instruction for that, like the HP calculators. Something that is new also compared to HP calculators is step out. That steps out of the current function and gives me the caller to that function. And as I mentioned, continue to keep going. One thing that is also very interesting is that if I go like this and I have a test, so I don't have a test in this one, so I'm going to kill it. But let me go to another example that we have in the demos folder. No, I don't want this one. So let me go to this, debug, and I will kill this one. So the one that I'm interested in is the Collatz conjecture. So the Collatz conjecture is this test where if you take a number and, sorry, I don't want the benchmark, I want the function itself. So you say that if a number is not 1, if it's even, then you divide it by 2, and if it's odd, then you multiply it by 3 and add 1. And the observation, we don't know exactly why, and I don't think there is a mathematical proof for that, is that you always end up with 1 in the end. And so you see that this is written with a recursion that ends inside an if. And we are going to run that now, starting, for instance, from 27. And let me swap and evaluate that program. Oh, and it's still in debugging mode. So let me continue. Continue, F5. And you see that it ended in 1. Now this was really fast to see it. So we are going to do that again on a real calculator to have a bit of time to see it. And if I start with 27, same thing, I was in debugging mode, so I need to exit of that, continue, and you see that it takes a while to converge back to 1. It's interesting that it resumed with the previous program because I was interrupted in the previous program, so not sure this is exactly what I wanted. So what you see here is that when you're interrupting a program, you're inside. You do not interrupt the pending debugging session. So you can call other programs while inside, while you're debugging a program, which is what I just did inadvertently here. So I need to kill everything to make sure that this doesn't happen. And now I can run my collapse conjecture again. So back from 27, which is a number that goes relatively high. And you see the time it takes to converge back to 1. And you see that despite the fact that the collapse call is inside my if statement, it still did not consume memory. So it still allows infinite recursions on RPL programs. So that's two of the new features there. It's infinite recursion and debugging. And these are introduced by relatively similar changes in the code. So the infinite recursion made the debugging support easier to implement. So I think this is it. There are many other changes that are internal. Notably, for instance, the setup menu finally obeys the silent beep. So if you use beep mode, and you see that when you do that, it triggers a silent beep. So let me first trigger a beep. If I go to the beep, I don't know if you can hear that because it's very faint, but this is there is a small beep when you hit the end of the edit line. If I go to setup, settings, and switch beep mute, so by default, this also activates silent beep. And what silent beep means is that when I hit my beep situation, I got this blinking of the screen. And I can switch that off as well if that annoys me. So like this. And now I have no sound and no visual effect. I think that's the majority of the changes. The settings were reworked internally quite a bit, which makes it much easier for me to add new settings and new flags to the code. So a number of things that should have been under control of various flags and were not are going to be in the next release. But for this release, we have covered the most important things. Oh, there is about settings. There is one new settings that is interesting. So if I enter 12.3 and I display a fraction like this, so you see that the fractions can now be displayed with small digits. And this is some of the settings that you can change, as you can switch back to larger digits if you prefer, or smaller digits. But you can also have mixed fractions like this. So 12 and 3/10, which, so if you want to have mixed fractions or improper fractions like this, so you can do one or the other as you prefer. So that's about it for the new features in this release. I have laid some groundwork for statistics as well, so I expect that the next one is going to be a 0.5.0 with support for statistics, but this is not ready for publishing yet. So I hope you enjoyed this video and talk to you next week. There is one last thing that I wanted to show, which is that like on the HP42, now you have a screen snapshot feature. If you hold Shift and Disp, then it's going to put the snapshot in the screens directory. So if now I activate the USB disk, and that gives me a window that I can show you here where I can go inside the screens and this is a screen snapshot I just took. Which I did not think about having the window show up there. So let me see if I can do that while recording. Okay, so this is the snapshot that I just took. And I don't know if it's really a good idea to do that while recording. I'm going to see if that works. So that's the idea on screen snapshots. Very easy, but if you want to report a bug, now you have this. I hold shift and I hit the display feature and then you can share with me the screen snapshot in the bug report. And that's about it.